In this video, I'm going to be introducing you guys to nested sets. So what is a nested set? Well, a nested set is just a set inside of a set. Like for example, this right here. We have the set that contains the number 5 and 8, right? And we have brackets around it. So this means that the set 5 and 8 is a set. And we also have brackets on the outside, which means that this set right here is in another set. So that is a nested set. End of the video. You don't need to know anything else. Of course, I'm joking. That's not the end. And you might be wondering why that's not the end. Well, nested sets have very, very tricky, at least in my opinion when I was learning this, had tricky symbols with the subsets and the within, or element of symbol. All right, these guys can be very tricky. And here's the thing. The reason why I crossed off all of these is because all of these are false, right? Every single one of these statements I wrote down here, right, aren't a subset or aren't an element of the set. So for example, 3, the set 3 is not an element of this set. Well, why is that? You see a 3 right here. There's a 3 right here. How is this the case? Well, here's the thing. Is the set 3 an element of this set? The set 3. I'm talking about the set 3 right now. I'm not talking about the number 3. I'm talking about the set 3. For example, if you had a set 3 right here, then this would be true, right? Now we have an element. Now the set 3 is an element of this set. But before, we didn't have the set 3 in here. Oh, go back to white. Which means this right here is not. The set 3 is not an element of 5, 8, 10, and 3. Well, how about this? Well, we have the set 5. Is the set 5 a part of this? What am I talking about? Is the set 5 a subset of this set? It is not. This guy is not a subset of this guy. All right? And this is the subset symbol, remember that? And keep in mind, the subset symbol is different than the an element of symbol. All right? These are two different things, and throughout this video, I'm going to give you practice problems that allows you or helps you differentiate them or what their different functions are. But for now, let's focus on this problem, right? This guy is not a subset of this. Well, computer engineering Jitty. Why? Why is that? I see the number 5 right here is computer engineering Jitty. Tripping? No, I never trip, and I never lie to you guys. Sometimes, okay, you know what? Sometimes I do, yeah, I've seen previous mistakes in previous videos, so I do trip sometimes, okay? If I do make a mistake, please comment it. I will correct it in the description. But is this a subset of this? It's not, all right? 5? 5. Huh. Why is that? Well, remember, what's the definition of a subset? Definition of subset is every element in this set must be an element of this set, all right? So let's go ahead and test that out. 5 is the value 5, or the number 5, an element of 10, 15, 5, 8, and 7. Well, we have a 5 here and we have a 5 here. But here's the thing. 5 must be an element of the set. Do we see the element 5 on any of the singular values? No, we don't. This entire guy, matter of fact, this entire set, 5, 8, counts as an element of the outer set. So this entire guy counts as one element, right? The number 5 also counts as one element. Is the number 5 equal to this one element? It is not. So 5 is not a subset of this guy because every element in this set does not exist in this set, okay? Every element in this set must exist in this set for it to be a subset. All right, so this right here is /5 is not an element of 10, 15, set 5, 8, 7. Therefore, 5 is not a subset of 10, 15, 5, 8, 7. All right. This can be a common point of confusion, but the more you see this, the more you will pick up on that pattern that I'm seeing right now. But for now, this is just an introduction. There's going to be way more practice problems in this video. I'm going to have way more explanation. So if you're confused on this, don't worry. There's going to be more. Don't worry about it. Now, let's take a look at this. All right, this last problem. Let's clear some space for this, matter of fact. Let's clear some space for this. So 6, 5 is not a subset of 6, set 5, 4, 9. Okay, why is that? Well, remember, in order to be defined as a subset, every element in this set must exist in this set. So let's go ahead and test that out. Is 6 an element of 6, set 5, 4, 9? Well, it is. Matter of fact, it actually is. We have a 6 here, and we have a 6 here. So 6 is an element of this set. All right, now let's go ahead and test out 5. Let's go ahead and test out 5. 5 is this 5 an element of this guy right here? 9. All right, is it? Well, it's not. Why is that? Remember what I said in the first problem I showed you in this video. 5, okay, is an element. The set 5 is also an element. Are these two equivalent? Is 5 equivalent to the set 5? It's not. 5 is not equivalent to the set 5, okay? 5 is a number. Set 5 is a set. They can't be equal, right? A number can't be equal to a set. So 5 is not an element of 6, set 5, 4, 9. Okay? So the number 5 cannot be equal to the set. Therefore, since this number 5 does not exist in this set, 6, 5 is not a subset of this guy. Okay? So remember, these withins and subset, they are different. And if you're getting confused, there will be more problems for you. How fun. All right, let's take a look at set A here. Now, the first thing I would like you guys to try to do or attempt to do, find the cardinality. Okay? Because that's an important part of understanding elements and nested sets. All right, now that you attempted it, you don't have to get it right. It's completely fine. I'll show you guys how to find the cardinality. Well, the cardinality of set A is 1, 2. Here's the thing. This entire set counts as one element. So this is 3, 4, 5, and 6. So the cardinality of set A is 6 because there's 6 elements or 6 unique elements in set A. Okay? Now, if you don't know what cardinality is, I have an introduction to sets video. I'll leave a link down in the description for you guys if you don't even know what a set is. But cardinality is the amount of unique elements in this set. Okay? And maybe just a quick review for those of you guys that don't know. If I have another 5 in here, technically the cardinality would still be 6, even though there's 1, 2, 3, 4, 5, 6, 7. There's 7 elements in the set. The definition of cardinality is unique elements, the amount of unique elements, not just the amount of elements. So now that there's 2 5 values, technically one of them doesn't even count towards the cardinality because, well, another 5 is not unique. Therefore, the cardinality is still 6, even if we were to add a 5 onto the end. All right, now that you know that, now that you understand that this set itself is an element, keep that in mind. That's very important, okay? This set itself is just a singular element of set A. Okay, let's go ahead and try this out. Is 9 a... Whoa, what am I saying? I'm losing my train of thought. Hold up. Is 9 a element of set A? Well, it is, right? The first value is 9. So 9 is an element of set A. So yes, this is true. Is 5, 9, a subset of set A? So what's the definition of subset? The definition of subset is that every single value in this set exists in this set. Okay? So every single value in this set exists in A. Well, we can test that out. We have a 5 here, and we also have a 5 here. We have a 9 here, and we also have a 9 here. Right? And let's check this out real quick. Is the 5 in any nested set? No, it's not. It's just in the outer set. Okay, it's in the entirety of set A. So this is fine, right? 5 is still an element of set A. Is 9 an element of set A? Well, it is, right? 9 is an element of set A. It counts towards its own cardinality. So yes, this right here is true. All right, is 1 an element of set A? Let's go ahead and look at this. Is 1 an element of set A? Well, we have a 1 here. But remember what I said about cardinality. This entire set, the entire nested set, it's its own element, is its own element. So 1, is 1 an element of A? Well, technically it's not, right? There's no 1 here. We have a 1, 2, 3, but we don't have just a 1. Okay? So 1 is not an element of A. This right here is false. All right? So remember, we need to look for a 1 that is not inside of a set. Okay? In set A for this to be true. But since 1 does not exist outside of any nested set, this is not true. Okay? All right, what about 767? But this is a subset symbol. So keep this in mind. There's subset, and there's a subset symbol here, and then there is an element of symbol. Those are two different things. So watch out for that. They kind of look similar. I'm not going to lie. I actually, you can like shift this. What if I were to do that? You can like shift this line up here. Oops. You can like shift this line up. Boom. The element of symbol. Okay, I'm just messing around now. All right. Is 7 and 6, 7 a subset of A? Well, remember subset, right? Definition of subset. Every element in this set must exist as an element in this set. Let's go ahead and test it out. Let's look at 6, 7 first. So 6, 7. Well, you found that right here, right? 67 is an element of A, right? It's not in any nested set, right? I don't see brackets around it or anything like that. So it is an element. What about 7? Well, 7 is right here, but it has brackets around it. So is the element 7 inside of set A? It's not. The element 7 is not inside of set A. It's in this nested set, but it's not in the set A individually. So therefore, this guy right here is false. 767 is not a subset of A. There will be more to come. There will be more to come. Let's take a look at these two. These two. What? I can't count now? These 4 new problems. Okay? So, we have 5 and 7, and we're asking if this is an element of set A. Go ahead and check this out. Is 5, 7 an element of set A? Well, remember what I said. Cardinality counts the amount of unique elements. And what did I say about this entire nested set? It is one element, right? 5, 7 is one element. Oops, undo a little too much. But 5, 7 is an entire element, right? So this right here, is 5, 7 an element of A? It is. 5, 7 is an element of A because we have the entire nested set 5, 7 in here. Okay? So remember, this is an element of symbol, not a subset symbol. A subset symbol would test if 5 and 7 existed in set A, but an element of symbol tests if this is just an element of set A. Okay? So they're different. Okay? A set can exist inside of another set, and that's exactly what we did right here. 5, 7 is an element of set A, right? Remember, we counted this guy as its own entire element. So 5, 7 is an element of A. All right, this is the subset symbol. So what do we do with the subset? We're testing each individual element. Okay? So an element of, test out the entire thing. A subset, test out everything individually. All right, so let's go ahead and figure this out. 9. Is 9. Let's use yellow, because red usually stands for false. Let's use yellow. Is 9 an element of A? It is. So far, this might be a subset. Is 10 an element of A? Yeah, it is, right? We don't see brackets around this or anything like that. So 10 is an element of A. Is 67 an element of A? Well, we have 67 here, and it's not inside any nested set. Therefore, they're all elements of set A. So this right here is true. Sorry, I'm not writing the entire thing because I just figured I didn't have enough space to write down true. I kind of took up too much space with these guys right here. All right, what about this? Is this set a subset of A? So remember, subset, definition of subset, every element in this guy, okay, must exist in A. So does 9 exist in A? Well, yes, it does. We just tested it out. 9. We figured 9 was an element of A, so this is true. But here's the thing. Is 1, 2, 3 an element of A? Well, remember, we test nested sets. We treat nested sets as a singular element. So you don't test 1, 2, 3 individually here, right? Because we have a nested set. We have brackets here. And you might have seen like this bracket just teleport and change into like the typed version. Yeah, okay. The previous bracket looked like a 3 So I just changed this to like the type of bracket to avoid any confusion. But do we test 1, 2, 3 individually? We don't. And the reason why is because we treat nested sets as a singular element, one element. So this entire thing is one element. So we test this guy as an element, okay? So it's 1, 2, 3, an element of A. Well, the set 1, 2, 3 is an element of A. We have the set 1, 2, 3 right here, right? Remember, when we figured out the cardinality, we treated all these nested sets. We treated all these nested sets as a singular element, right? So 1, 2, 3 is its own element, and 1, 2, 3 here is also its own element. Therefore, 1, 2, 3 does exist in set A. So this guy is a subset of A. Okay, we tested out each element. So remember, we tested out each element in this set right here, and we tried to figure out if all these elements were an element of A. Now let's move on to the last problem for set A. Now here's the thing: these problems are still not that tricky. I'm gonna change this. When you see set B here, Jitty has turned evil. I'm gonna make very annoying problems for you guys. It's gonna have like brackets upon brackets. Trust me. Watch that, because those problems might actually be on your exam. But let's go ahead and look at this. All right. So is the set 7 an element of A? Well, we see the 7 here, but 7 is in a nested set. It's in a nested set. But the question is this an element of A? It's not. Okay. And the reason why it's not is because the set 7 is not by itself. If we had like a comma here with 7, all right, then this would be true. This would be good. But we don't. We don't just have the set 7 by itself, okay? Remember, the set 7 must be by itself in order to be an element of A. But since it's not by itself, since the number 7 is with the number 5, this is not an element of A. But now that you guys get this, review a little of these, okay? Review a couple of these problems that you see on screen right now. Try to understand them and prepare for problem B. Ooh, maybe I've gone haywire here with this problem. I'm having jitters right now making this problem and thinking about explaining this. They're excited jitters. They're excited jitters. But let's get to the problem. We have a null set, and we're asking if this null set is a subset of B. Well, here's the thing. The null set is always a subset of anything, all right? Right, the null set is always a subset of anything, so this is true. Okay, automatically if you see null set and you see the subset symbol with literally any set, unless it just wrote completely nothing here, then it's always going to be true. So automatically this is true. How about this? Is the set 7 a subset of B? So remember, the definition of a subset is what? Definition of subset is that every element in this set must exist as an element in this set. So let's go ahead and test that out. Is 7 an element in B anywhere? Well, we have a 7 here, right? We have a set inside of a set. Sorry. Yeah, we have a set 7 inside of the outer set, right? But we don't have the element 7. We don't have just the element 7. Is there just the element 7 here anywhere? It was no 7s. Therefore, this is not. This is false, okay? Because the element 7 does not exist in set B just by itself. All right, what about this? Is the set 7 an element of B? Okay, we asked this basically the same thing, but we just switched the subset symbol to an element of symbol. Is this true? It is. It is true. Because the set 7 is here, right? The set 7 is right here. The set 7 is an element of set B. So this is true. All right, what about this? Is the null set inside of a set an element of B? So remember how I said the null set is automatically an element. Sorry, and automatically, just the null set by itself is automatically a subset of any set. Well, here's the thing. I put the null set around brackets now. Is this still true? Let's go ahead and test this out. So in order for this to be true, remember the definition of a subset. Every element in this set must exist as an element in B. So does every element here exist as an element here? Or just a singular element in this case? Well, yeah. Right? We have the null set here, and we also have the null set here, right? The null set is an element of B. So this right here is true. All right, let's go ahead and test this last one out. Is the null set inside of a set an element of B. So remember, what is the outer set? What's the definition of a subset? Okay, keep going back to the definition of subset. Is every element in this set an element of B? Well, here's the thing. We have these outer brackets. So these outer brackets represent the entire thing, right? These outer brackets represent the subset that we are testing. But we have the null set inside of brackets again. Well, what's going to happen here? Well, here's the thing. We're just going to test out this inner set, okay? We're just going to test out this null set inside of these brackets. We don't have to care about these brackets for now. So is this guy, the null set inside of a set, an element of B? Well, we have something that kind of looks similar. We have this. But we have the null set inside of a inside of a set, inside of another set. This is like setception. Okay? There's so many sets together. This can be confusing. But I'm going to tell you this one real quick. This is false. And that's because this guy right here, right? The null set inside of a set is not an element of B. Okay? It is not an element of B. I don't see just this anywhere inside of set B, right? We have 5, 8, we have 12. We have the null set inside of a set, right? But we don't have just the null set inside of a set. We have the null set inside of a set, but we don't have the null set inside of a set. Holy crap. That's just word vomit right there. But hopefully you get what I'm saying, okay? Hopefully you get the logic. All right? And remember, this is not equal to this, right? We have brackets here, but we don't have brackets here. So this right here is false. Now, here's the thing. What if I wrote this instead? What if I used an element of symbol for B? All right. So basically, all I did for this was turn the subset symbol into an element of. Is the null set inside of a set an element of B? It is. We have that right here, right? We have the null set inside of a set, and we also have the null set inside of a set here. These two are equivalent, right? So this right here is true. See how tricky this can get? Especially with the subset and an element of symbols. All right, on to the last stretch. But I'm telling you, if you could do all of these problems, you'll be pretty well set. Pun intended, by the way. Pretty well set for any exam related to nested sets. Let's go ahead and start this. All right, is the set 5, 8 inside of another set an element of B? Well, let's go ahead and look for something that looks similar. So we have 5, 8 here. Do we have 5, 8 anywhere? Do we have 5, 8 anywhere? Oh, right here. We have oops, I deleted the B. We have 5, 8 here. But is this set 5, 8 inside of another set? It's not, right? We're looking for the set 5, 8 inside of another set, right? Because this is an element of symbol. Remember, this isn't the subset symbol. So do we have a double nested set anywhere in this set B with the elements 5 and 8? We don't, right? We don't. So this is false, okay? Now, if this was switched to the subset symbol, that would be true, right? This statement would have been true, but we're looking for an element of. So is the set 5, 8 inside of another set an element of B? It's not, because we don't have another bracket here. All right, what about this? This is a subset symbol, so we're going to test out every element in this set to see if it's B, right? So see if it's in B. So we have 12. Well, 12 is in B, so 12 is right here, right? So far, so good. But how about this? Is the null set inside of a set an element of B? Well, we have the null set inside of a set, but that's not equal to just the null set inside of a set, right? There's an extra bracket here, right? So far, not this. We're still testing this, by the way. And we have a null set here, but we don't have brackets around this null set, right? We have brackets around this null set, but we don't have brackets around this null set. Therefore, this guy is not an element of B. So this set right here is not a subset of B. Let's go ahead and write down. No, not true. False. All right, how about this? Is 5, 8 an element of B? Okay, is 5, 8 an element of? This is important. An element of, is it? Well, we have the set 5, 8 right here. So it is. Okay, the set 5A is an element of B. So previously, before, we have two brackets here, and we're asking if it's an element of B. But now we just have a singular bracket. So since there's a singular bracket here, and there's a singular bracket here, right? The set 5, 8 is an element of B. Therefore, this is true. Or how about this? Is 5, 8, 7 a subset of B? Well, remember, we already know that 5, 8 is an element of B, right? So we're gooch on this, right? But is 7 an element of B? Remember, the number 7 itself, not the number 7 in any subset. Sorry, not the number 7 in any set, just the number 7, okay? Not 7 in a set. Well, we have 7 in a set here, so that excludes this. This is just the number 7. And we have 7 inside of a set here. So this excludes this as well, right? We don't just have the number 7 anywhere in here. So that means this guy, the number 7, is not an element of B. Therefore, this right here is not a subset of B. Okay, so this is false. All right, let's move on to this last guy right here. Kind of looks like a monster. We have a 7 inside of a set, inside of a set, inside of a set. But we're looking for a subset. So what's the definition of subset? Remember, definition of subset. Every element in this set is an element in B. So what is this set? Well, this set is defined by these outer brackets. So that means a singular element is the set 7 inside of another set. Okay? So is this guy an element of B? Well, matter of fact, it is, right? We have 7 inside of a set, inside of a set. We also have 7 inside of a set, inside of a set here. This is perfect. They are equivalent, right? Therefore, this guy is an element of B. So every element in this set is an element in B. Therefore, this is true. All right. I know this video is long, but if you stuck with me this long, then you're probably a genius at nested sets now and the within and subset symbols, okay? But, you know, I used to end my middle school presentations with the end, right? I'm pretty sure everyone has attempted to do that at least once. It was a horrible ending, but I was like, you know what? Why not end this video with the end? So this is the end. If you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.